example. Now we start with the next point, first point, equality of matrices. What is the equality of the matrices? So say let A is equal to Aij M cross N and B is equal to B is equal to Bij M cross N. Two different matrices are given. See here both having same order. So you can say the two matrices with the similar order given. For every I and j, if Aij equal to Bij, this is the important thing. If Aij equal to Bij, then these two matrices A and B are called equal matrix, and that we represent as A equal to B. Means when you say A and B are equal matrix, so say if they having the same order and they having the same kind of element, then that two matrices are called the equal matrix. Supposed to be given like this: X, Y, P, Q, and another matrix 3, 4, 5, 6. Here these two matrices are equal. It means what? So say this corresponding elements are equal. Means you can say that X is equal to 3, Y is equal to 4, P is equal to 5, and Q is equal to 6. So in equality of the matrices, two things should be needed. First, their order has to be same, and the second, they have a same elements. Then that two matrix we call as the equal matrix. Some important examples given related. Now we start another example too, which will be given in your exercise 3.1, sum number 7. A minus B 2A plus C, 2A minus B 3C plus D is equal to another matrix given minus 1 5 0 13. See, by definition of equality of matrices, this corresponding elements are equal. So we can say A minus B is equal to minus 1, 2A plus C equal to 0, 2A minus B equal to 0, 2A plus C equal to 5, and 3C plus D is equal to 13. Now these two equations having the same variable A and B, so we can solve them as a linear equation of two variables. You can use the elimination method or a method of substitution. Here B, we use a substitution. Say 2A minus B is 0. So can I say B equal to 2A? Now that value we keep in this first equation. So A minus B is minus 1, but B is what? 2A. So A minus 2A is minus 1. So A minus 2A is minus A. So minus A is minus 1. So A becomes 1. Now this value of A we keep here. B is equal to 2A. So A is 1. So 2 into 1 is 2. Now for this 2A plus C is 5. We use A is 1. So it is what? 2 plus C is 5. So C will be what? 5 minus 2. So C will be what? 3. Similar way, C will be 3 here we use. So 3 into 3 plus D is 13. Is that clear? 3 3s are 9 plus D is 13. So D is equal to 13 minus 9. So D is equal to what? 4. So like this, by using the definition of equality, we can find the unknown variables. See, in this textbook, so many like this sums given that you have to solve. See, I show you some different example. जैसे कि sum number 2. You can use a textbook. See, that will be from the exercise number 3.1. If a matrix has a 24 elements, you can see the textbook. If a matrix has a 24 elements, what are the possible orders it can have? What if it has 13 elements? Very simple example. See, the matrix having how many elements? 24. So we have to identify that order, means m by n. So just you have to make it, the product will be what? Mn, means m into n is mn. So here we have to find out the two numbers whose product should be 24. So that becomes a different orders of the same matrix. So that may be possible. 24 ones are 24. That may be possible 1 into 24. This is the first and second possibility. Means the 24 rows, 1 column. Or maybe the 1 rows and 24 columns. Now you can use a factor of this 24. You know that 8 3s are 24. So, or you can just increase this 1. 2 12s are 24. So you can say 12 into 2 or 2 into 12. Now 3. So say 8 into 3 and 3 into 8. Like this, you can say 6 4s are 24. So 4 into 6 and means 6 by 4 or 4 by 6. Now, is it there anywhere? Check. I don't think so. Another way you can say like this. Just make it the factor of 24. Can I say 1, 2, 3, 4, 6, 8 and 12 and 24. These are the factors, so I have used them only. Another part is given. The number of elements are 13. How many ways possible? So you know the factor of 13 are what? 1 and 13. So you have only 2 elements. So you can make it like this. 1 cross 13 and 13 cross 1. Understood? So see, in this exercise you have this type of question, equality of order pair. And there is also one kind of question in a sum number 4. So this is a very good question. Construct 2 by 2 matrix. Construct 2 by 2 matrix where A is Aij, means A is Aij, and this is 2 by 2 matrix whose elements are given below, where number 1, Aij is what? I plus j whole square upon 2. See, there are different Aij possibility given in the book. I show you this one, rest one you have to try. And if doubt, I will show you. See, A is equal to Aij 2 by 2 matrix, means it has 2 rows and 2 columns. 2 by 2. 2 rows means the elements are, can I say, A11, A12. Second row is what? 21, 22. I think you know the first row having A11, A12. Second row having element A21, A22. So now we have to find out the rest of the values only. A11 means I is 1, j is 1. So we find out the element A11 by using this formula. So you can say 1 plus 1 whole square upon 2. So that will become 1 plus 1, 2 square is what? 4 by 2. That is 2. So what is the element A11? So say 2. Similar way, A12 means your I is what? 1, but j is 2. Just compare. So 1 plus 2 whole square upon 2. So that is a 3 square is what? 9 by 2. Similar way, A21 means your I is 2, j is 1. So that means 2 plus 1 whole square upon 2. So again it is 9 by 2. Similar way, last element A22. So just compare Aij. I is what? 2, j is 2. So that is 2 plus 2 whole square upon 2. So 2 plus 2 whole square means 4 square is 16 by 2 means what? 8. So matrix A is what? Your matrix A will be A11. First element is 2. This is the element of A12, that is a 9 by 2. This is again 9 by 2, 2, 1, and A22 is 8. So like this, you have in this exercise these 3 different kinds of sums. So first you have to by heart all the definition. By heart in the sense, first you see the definition, at least you understand the definition. Second sum, equality of a matrices. Third, if a number of elements are given, how we find the different orders. And fourth, that last one we have seen, how to construct this matrix. Is that clear? Now please try to solve exercise 3.1 at home. Tell me the doubt. I will send the new means addition of the matrices, next topics next time. Okay, good day everyone. Good morning student. I think you have completed exercise number 3.1. You understood what is a matrix, different forms of the matrix, equality of a matrix. Now the next point is addition of a 2 matrices or addition of a matrices. Suppose you have given some matrix. A is supposed to be a 2, 3, 7, 5, 8, 9. This is a matrix of 2 by 3. Another matrix B given as A, B, C, D, E, F. This is your matrix B. This is also a 2 by 3. And another matrix supposed to be C given. That will be like this: 2, 1, 7, 5, 8, 9. This is your matrix of a 3 by 2. See, A and B having the same order 2 by 3, while the C is having the order 3 by 2. Now what is the definition of the matrix A and B? So say when you have 2 matrices, like suppose A is equal to Aij, M cross N, and B is equal to Bij, M cross N. If a 2 different matrices given, the addition of the matrix, say definition says A plus B is simply a addition of the corresponding element, means Aij plus Bij, and that outcome will be also M cross N matrix. So the first condition should be, if their order is same, then only the addition possible. So here, what is A plus B? So say A plus B is, we can say like this, again I write 2, 3, 7, 5, 8, 9. This is a matrix of 2 by 3, plus another matrix is A, B, C, D, E, F. See, this is also 2 by 3. So what is the outcome of A plus B? So simply we have to add up corresponding element. Means Aij plus Bij. A plus B is what? Aij plus Bij. So if I take A11, so you have to add up with what? B11. Means it becomes 2 plus A. If it is here 3 given, so 2 plus 3 becomes what? 5. Now this second element, so say this 3 plus B, so it becomes 3 plus B. Third component, 7, we have to add up with the C, so 7 plus C. Likewise, we have to find out the second row, so this 5 we have to add with the D, so it is a 5 plus D. Like this, 8 plus E, 8 plus E, and 9 plus F. So like that you get it another matrix which is addition of A and B, which is also in the form of 2 by 3. It's very simple. But see, if you add A and C, it is not possible because they are in a different order. 2, 3, 7. This is 5, 8, 9. Plus this side, the matrix will be what? 2, 1, 7, 5, 8, 9. Okay. So this is a matrix of 2 by 3 and this is a matrix of 3 by 2. See, you can add this two, but what about this element? Here not given. So addition of A plus C is what? Not possible. So the important thing is when the addition of the two matrices is possible, so say they are every in the same order, and just we have to add a respective elements. Is that clear? I show you another example of that. Stop. Hello. See, this is a second video of addition of the two different matrices. Now see this example and we understand again the what is the addition of the matrix. See, A given a 2 by 3 matrix with the element 2, 5, 8, minus 4, 3, 7, and B is another matrix that we can say 5, 11, 0, 3, minus 4, 5. Both are a 2 by 3 matrix. So A plus B is what? So we can say 2, 5, 8, minus 4, 3, 7. This is 2 by 3 plus another matrix 5, 11, 0, 3, minus 4, 5. This is also a 2 by 3. See, when you add up, you have to add a corresponding elements, means this 2 plus what? 5. This 2 and that 5. Like this 5, this 5 and this 11. So plus 11. Why we have to add this? You know, this is the element of first row, second column. This is the element of first row, second column. So that corresponding element we have to add. Like this 8 plus 0, minus 4 plus 3, 3 minus 4 and 7 plus 5. So the outcome will be what? So say 2 plus 5, 7, 5 plus 11, 16, 8, minus 1, 12. Understood? It's very simple. Now you know that. You say that a 2 plus 5 or a 5 plus 2. The thing is similar one. You know that if you add real numbers in any way, commutative property is there. So same thing here, we can also see some properties. Some properties means we can easily understand. To be A plus B, two matrix given, you can say as the same as a B plus A. You can carry out the operation here also. If I do B plus A, the thing is same. 5 plus 2, 11 plus 5, 0 plus 8. So there is no problem. Similar way, second property, you can say that if you have given A plus B plus C you can say that A plus B plus C. I think everyone know this is a commutative property. This is a associative property. Third one, additive. This is the important. Additive identity element. See, for the real number, you know that 5 is a real number. What is the additive identity for a real number? So say 0. So say 5 plus 0 or a 0 plus 5 is what? 5 itself. So like this, M cross N is a identity matrix, you can say. Because if you take any matrix, A is Aij any matrix, M cross N. So their addition will be what? A plus O or O plus A is same as what? A matrix A. Matlab, if you add any 0 to any number, it remain as it is. So like this in the matrix also you can say. Similar way, fourth and last property, additive inverse. In that case, supposed to be A is any matrix given Aij, M cross N. We can find a minus A as a minus Aij, M cross N. Then their addition will be what? A plus minus A, or minus A plus A will be what? 0 M cross N. Is that clear? Means we can find just opposite matrix. I give you one more example related to this. See. Hi. See, after the addition of the two matrices or addition of the two matrices, now see the next point is the multiplication of the matrix with the scalar. Now scalar means what? So say any real number given. Means supposed to be A is equal to Aij, M cross N matrix given, and K is any real number given. If you multiply K to this matrix, then it is what? K into A. K into A. Means this K we have to multiply to the each and every element of the matrix, that we call as a multiplication of the scalar with the matrix, and the outcome will be also as it is. Just I take one example. Supposed to be given A is 3, 2, minus 1, 5, 7, 8. Supposed to be we have to find out 7A. Means this 7 we have to multiply to each and every component of this matrix. So 7A will be what? So we have to multiply 7 3s are 21, 7 2s are 14, minus 7, 7 5s are 35, 49 and 56. Outcome will be the same as 3 by 2 matrix. Means the remain as it is. Its order will be remain as it is. Now by using this addition of the matrix and multiplication of the scalar with the matrix, we can also find the difference of the matrix. Difference of the matrices. That is also nothing but A minus B. Means what? Just simply we have to take the difference of them. Means Aij minus Bij. Now we perform one example based on that. 3. Now first we see the properties of the matrix. Supposed to be A is Aij M cross N and B is equal to Bij M cross N matrix given, and K and L belongs to R given. You can understand K is any real number into A plus B. We can say as Ka plus Kb. Similar way, if a two real number K plus L into A given, you can write as a Ka plus La. Now these three things, addition of the matrix, difference of the matrix and multiplication of the scalar with the matrix, we see one example. See the A 2 by 2 matrix given, B also 2 by 2 matrix given. We have to find out 2A minus 3B. So say 2A minus 3B means 2 into, see, don't do directly, show each and every operation initially. Once you get it, then no problem, but write each and every step. Minus 3 into this 3, 6, 5, minus 2. If I multiply, so first of all, multiplication of the matrix means this 2 we multiply inside this matrix. So 2 7s are 14, 3 2s are 6, minus 2, 10. Similar way, minus keep outside only, 3 you take it inside. So 3 3s are 9, 18, 15, minus 6. Now we take a difference of them. So you can, well, you can write directly, no problem, but I write each and every step. 6 minus 18, minus 2 minus 15, and 10 minus of minus 6. So your outcome will be 14 minus 9 is 5, 6 minus 18 is minus 12, minus 17, and this minus and minus become plus, so it will be what? 16. This outcome is also 2 by 3. So are you clear about this? How we find, we are clear about this, how we find addition of the matrix, difference of the matrices, and multiplication of the scalar with the matrices. Now in exercise number 3.2, some sums are given based on this that you have to try. Now the next point is a very, very important point, that is multiplication of the two matrices. This is a very, very important and difficult form of this chapter.